Is everybody on their pockets? Are you ready? Can you see up front? Okay. Are you ready? Because we have a special guest here at the library. Usually you come and you get me, but today you get Jetpack Jason. What? How cool! Let's give him one big, really big clap. Are you ready? 1, 2, 3.
Awesome! Well, thanks, guys. I am Jetpack Jason. That is my name. Now, I am a mad scientist. I did bring with me a bunch of really fun science stuff that we're going to get to do, all about the celebration of the, well, what are we celebrating this summer? What happened 50 years ago this summer? Anybody have any idea? Thanks for raising your hand. What do you think?
The Earth.
The Earth happened 50 years ago. That happened a little bit longer ago. That's a good guess. That's cool. All right. Let's see. What happened?
Apollo 11 landed on the moon.
Apollo 11 landed on the moon. You got it. Yes. Very good. Okay, round of applause. Yes. It did happen 50 years ago today. Or not today. This summer on July 20th. Now, guys, I did bring with me a bunch of science that we're going to do all about space and getting to the moon and rockets. But I have 3 rules to cover with you guys before we get started. Can we follow 3 easy rules? Okay, my first rule, guys, since there's so many more of you than there are of me, while I'm talking, guess what I need for you to do? Yes, please do not talk while I'm talking, because I have to talk really fast like this, and if you're talking while I'm talking, nobody's going to hear what I'm saying. You're not going to hear what I'm saying, I'm not going to hear what I'm saying, people in the background can hear what I'm saying. Like I said, I got to talk really fast like this, so did you catch all that?
Yes.
Okay, if you didn't catch all that, just know this. Please, don't talk while I'm talking, and we got it covered. Cool? Sound good?
Yes.
Awesome! And if you have a question, what are we going to do?
Raise your hand.
Hey, let's try that again. If you have a question, what are we going to do? Yes, raise your hand. Awesome. All right. So, brings me to my second rule. Guys, I need everybody here staying seated right where they are, on their pockets, on the floor. Because that way, one, I know that you're safe. There are things up here that can be kind of dangerous if we don't know how to use them. And that way, people behind you can see also. There's also this nifty tape line right here in the front, and I need to make sure that everybody's fingers and toes, every part of your body stays behind the tape line. All right? Sound good? Cool. All right, so my first rule, please don't talk while I'm talking. Second rule, don't touch anything up here on my table. Just stay seated right where you are. And that brings me to my third rule, my favorite rule. It's 2 words long. Let's see, somebody have a guess what they think my third rule is? Oh, thanks for raising your hands. What do you think my third rule is?
Have fun.
Have fun? Have fun? What kind of a third rule is have fun? It's an awesome third rule is what it is. And it really is my third rule. So, on the count of 3, I need everybody to say that third rule, have fun, all together on the count of 3. Are you guys ready for this?
Yes.
Here we go. 1, 2, 3. Awesome. I think we are about ready to have some fun. Now, I actually need 3 volunteers to help me out here. By the way, whenever I pick volunteers, I pick people who are following my rules. People who are sitting quietly with their hand in the air, who aren't jumping up and down or yelling at me, going, because people who are yelling at me, I know are not listening, because I need good listeners, because there are directions to follow when you're helping me out of here. And the other thing is, if you're jumping up and down next to all my stuff, is that going to be the safest thing? No, definitely not. All right, so my 3 volunteers here. All right, you gave me the have fun. You got to come help me. All right, 1. Can you come help me this time? 2, and how about somebody way over here? Can you come help me too? Come on up here, guys. Awesome. All right, can you come stand right over here? Face all your friends. What's your name? Layla? Everybody say, what's up, Layla?
What's up, Layla?
All right, can you stand right over here, buddy? What's your name? Cole? Everybody say, yo, Cole.
Yo,
Cole. And what's your name?
Elijah.
Elijah, stand right here. Face all of your friends. Everybody say, what's up, Elijah?
What's up, Elijah?
Today, like I said, we are celebrating. We are kicking off our Walking on the Moon and this whole universe of stories coming up this summer for the summer reading program. And so we're going to celebrate a little bit, but what better way to celebrate with something with some balloons? Now, what I need for you to do, Mr. Elijah, is hold on to that right there really, really tight. Don't let go. And you can hold on with your other hand right there. Perfect. Awesome, you got that. Now Cole, I'm going to do the same for you. Can you hold on to that right there? Perfect. And hold that really tight so that way you don't let any air leak out of there. All right. And then same thing with you, Layla. Can you hold on to that? There we go. Now, here's what we're going to do. We are going to celebrate here in a second, but first we have to talk about some science about what's just going to happen right now. So, these balloons are full of what? Full of air. And that air is wanting to escape. It's wanting to come out where these guys are holding on to that hole. So, let's see. This is all about Newton's third law of motion. Newton's third law of motion is my favorite one because that's what helps my jetpack fly. And also, that's what helps rockets go. All right? So, what it says is where there's an action, there's an equal but opposite reaction. So what that means is this air coming out of here, Elijah, hold this up really high here so everybody can see. This air is going to want to come out going this direction. That is our action. So our equal but opposite reaction is going to be our balloon going where? Up! You got it, yeah. So it's opposite, right? So that's going to go that way, but the balloon's going to go this way. Maybe. What? It's mine. Yeah. So let's say, before we try this again, we're going to say that Newton's third law altogether, because this is the really, really important thing to get us to the moon. So, where there's an action, say that, where there's an action, there's an equal but opposite reaction. Close enough. Everybody put your hand up in the air like this. Give yourselves a big old pat on the back. Just like that. Good job. You guys got Newton's third rule down. Now, or third law, my bad. Can you guys point your balloons somewhere, anywhere you'd like, just not at any certain person at all, all right? And on the count of 3, we're going to let them go. Are you guys ready? Yeah! Here we go! 1, 2, 3! Guys, give my volunteers a huge round of applause for helping me out here. Very cool. Thank you so much. Oh, it's fine. Perfect. I'll take that. Awesome, I appreciate it. Can you guys grab a seat for me? Very cool. Let's give them another huge round of applause. Awesome. Now, you guys, we are about ready to explore all about our Earth and our moon and getting to the moon. But first we have to figure out kind of this place or this area of space all around the Earth. And that's like, well, you know what? Just to show you guys, I'm going to need this many volunteers to come help me out here. And remember, who do I pick? I pick people who are sitting, who aren't yelling at me, who are listening, right? Let's see, I need 9 volunteers to come help me here. All right, and let's see. Can you come help me here in the green? All right, and can you come help me? That's 2. Can you come help me? 3. Let's go over here this time. Can you come help me? 4. This guy way back here in the red, can you come help me? Way back in the very back. Yeah, in the red. You, bud. Both of you, come on up. There we go. All right. Let's see. We got 1, 2, 3, 4, 5, 6. Come on up, bud. You got orange. You're fine. You're cool. I can use an orange person as well. Let's see. That's 6. I need 3 more. How about this lady in the pink? You have to help me. And this dude in the blue, you gotta come help me here. All right, let's see. Is that, well, I do need 1 more. You know what? I need even a darker blue. Yeah, can you come help me here too? All right. Very cool. Now, we have all of our volunteers here to help me out. These volunteers, guys, are now our planets in our solar system. Except for you, buddy. You know why? Because you're wearing orange. You get to stand right over here. And instead of being a planet, I'm going to have you be our sun. You look really bright today. You're very orange. I think you're a perfect sun. What's your name, bud? What was it? Macklin. Macklin? Awesome. Everybody say, what's up, Macklin? Right up here for me. Right up here. Perfect. You are our sun right here. So this is our sun. Say that with me. The sun. Perfect. And next, I I think I'm gonna need, what's our first planet? Closest to the sun. What's the closest planet? Mercury! Can you be, let's see, I think this lady right over here in the pink, can you come be Mercury? Come right on over here. So you stand right here. Right, there we go, awesome. What's your name? Sierra? Everybody say, what's up, Sierra? Now, Sierra is now Mercury. Everybody say, yo, Mercury! Yo, Mercury! Awesome. And you, can you come stand right up here? Right next to Mercury. Maybe scoot back this way just a little bit. There we go. Awesome. What's your name? Brooklyn. Awesome. Everybody say, yo, Brooklyn. Yo, Brooklyn. Now, what's the next planet in our solar system? We have Mercury. Then what do we have? Venus. Venus. Very good. So we have Venus here. Awesome. So we have the sun. We have Mercury really close to the sun. And I think you're going to get really warm getting that close to the sun. I feel him radiating. He's really hot. All right. And then we have Venus. What comes after Venus? Earth. Oh, it's right where we are. Where are we? Earth. All right. This guy right on over here in the really dark blue. You got to come help me out. You are Earth. Earth is the same size, roughly, as Venus. The Earth is actually just a little bit bigger in real life, but this Earth is a little bit smaller, but that's okay. So, what's your name?
You're mini Earth.
What was it? Everybody say, what's up, Carson?
What's up, Carson?
Now everybody say, yo, Earth.
Yo, Earth.
Awesome. What comes after Earth? Wow. Your arm looked like it was about ready to fall off there. That was really fast. All right, what's next?
Mars.
Mars! Well, you know who's got to be Mars, right? This guy right here wearing the red. All right, can you stand right over here? Be Mars for us. Mars is actually smaller than the Earth, but that's okay. There you go. What's your name, bud? Henry. Everybody say, what's up, Henry?
What's up, Henry?
All right. Now, that is our inner planets. So let's review. We have the sun. What's next? Mercury. Then Venus. Then Earth. Then Mars. Now, what's next? Let's go over here this time. What's next?
The asteroid belt.
Dude, yes, the asteroid belt. You know what? That one's going to be pretty tough for us. But let's imagine that there is an asteroid belt running right through here. I like that. Thank you for that. So what comes after the asteroid belt? Right back here in the purple. What comes after the asteroid belt? Jupiter! Guess who you get to be? You get to be Jupiter because you are our tallest volunteer. You're our biggest volunteer. And Jupiter is our biggest planet. So you are Jupiter. But let's scoot out this way a little bit because there's actually a lot of space between Mars and Jupiter. Keep going. There you go. Perfect. What's your name again? Barrett. Everybody say, yo, Barrett.
Yo, Barrett.
Now everybody say, hey, Jupiter.
Hey, Jupiter.
All right. What comes after Jupiter? Let's see. What comes after Jupiter? Oh, not Mars. Mars was right over here. Let's see. What comes after Jupiter? Saturn. Saturn's one of my favorite planets to look at because what's special about Saturn? What does it have? It has rings, exactly. So, I tell you what, can you guys scoot this way a little bit? We're going to let a girl be Saturn this time. Can you come stand right over here and be Saturn for us? And make your hands right up above your head like this. Make a ring with your arms. There you go. Perfect. And what's your name? Monroe. Everybody say, what's up, Monroe? Everybody say, what's up, Saturn?
What's up, Saturn?
All right. After Saturn comes what?
Uranus.
There it is. Uranus is next. All right. What's your dude? You are wearing the perfect color because Uranus. That's what my astronomy teacher in college always called it. My astronomy professor. Sorry, he called it Uranus. It's actually a pretty cool name. So this guy right here is Uranus. Everybody say, what's up, Uranus?
What's up, Uranus?
Yeah. All right, we got it. Now, this guy right here is now Uranus, and after him comes what? Wait. Actually, you're right. There is something really cool about Uranus. It's tilted on its side, and it also has rings, and they're sideways. It spins funny compared to like Saturn and all the other planets. All right.
What's Cooper?
Cool, don't hurt yourself. All right, now, after Uranus comes what planet? Flash? Neptune. Neptune, you got it. And Neptune is a blue planet, so we have this guy right here. What's your name, bud? Cooper. Everybody say, what's up, Cooper? Everybody say, what's up, Neptune?
What's up, Neptune?
Now, hold on. I'm glad you brought that up. Now, you know, this guy right here brought up a really good point to me just now. He says, what about Pluto? Well, I gotta tell you what. A few years ago, some scientists got together and decided that Pluto doesn't count as a planet anymore. Yeah, right? That's not fair because Pluto was a planet for the longest time. Because Pluto is so small, there are other rocky objects in our solar system that are just as big or bigger than Pluto. And so all of these other ones would have to be included if we include Pluto. Well, I think that's a bunch of baloney because when I was your age, Pluto, yeah, I know you're making me hungry too. Now, Pluto was a planet when I was your age, so we have to include Pluto. So I tell you what we're going to do. I'm going to need one more volunteer to come help me up here and be a Pluto for me. Let's see. How about this lady way back here in the pink rainbow shirt? Can you come help me? Come here. Come on over here. Come be Pluto with us. All right.
She is pretty small, so she's the perfect person.
Dude, you got it, man. Come right on over here. Come right on over here. Awesome. Can you come stand right here, face all of your friends? Perfect. Guys, I would like to introduce to you Pluto. Everybody say, hey, Pluto.
Hey, Pluto.
Awesome. Can you stand right here for me? I don't think you're going to move. Stay right there. Don't move. Don't go anywhere. Stay right there. Now, let's go through and review our planets and our sun, right? So our sun is right here. What comes next? Mercury. Let's say it all together. What comes next? Venus. Then Earth. Then Mars. Then Jupiter. Then Saturn. Then awesome. You guys, give my volunteers here a huge round of applause. Awesome, guys. And can you guys go take a seat for me now? Awesome job. Thank you so very much. Very cool. All right. And can we leave that tape there for me, bud, please? Thank you. Now, we talked about all these planets. You guys did a great job remembering these planets. And we figured all this out. But now, we need to zoom in on our Earth and our moon. Now, I got a question for you before we do that. Is Earth the only planet that has moon?
No.
No. Jupiter has many moons. Yes. Go ahead. Saturn has many moons too. That's tough to say, I know, right? So, yeah, actually Mars has 2 moons. Pluto even has a moon. But we're going to focus on Earth and our moon for right now. Now, I need 2 more volunteers to come help me here. Let's see. How about this guy? Can you come help me here? And this lady right over here in the pink, can you come help me? All right, can you stand right here? And this lady in the pink, can you come stand right over here? Awesome. What's your name, Jack?
Jack.
Oh, okay, awesome. Jack, face all your friends. Everybody say, what's up, Jack?
What's up, Jack?
And what's your name? Emelina? Everybody say, what's up, Emelina? All right, now you guys are going to help me to figure out our Earth broke. Oh, no. That's not what Earth looks like. Did you ever want to see the inside of the Earth? That's what it looks like. Yeah, that's lava and magma.
It's orange.
All right, now, let's see. My planets keep falling apart here. Let's go. There we go. Perfect. Now, we're going to take, and I'm going to hand this here to Jack. You take, go ahead and hold on to that. Perfect. Stand right up here for me. All right, hold on to that. Really tight. There you go. Awesome. Now, this is the size of our Earth. No, I'm just kidding. Our Earth is a lot bigger than this, right? Yes, we're actually on it. I wish I could have brought Earth with me in through the door, but it wouldn't fit. So I had to leave it outside. We're on Earth, aren't we? Now, there we go. Now, that's awesome. Well, guys, our Earth, we have to use a model here. Because I can't fit the moon in this room either. Now, hold this up for us. Hold it way up here. Perfect. Hold on. right there. There you go. Hold it up. There you go. Now, guys, our Earth, if it's this size, means that our moon is going to be this size right here. So I know it looks pretty small, right? It is small. Now, it is a ping pong ball. Now, here's what we have to do. We have to figure out how far this moon is going to be from our Earth. So, let's see. I want you guys to tell me, like, is it going to be this close?
No.
Alright, tell me when to stop. I'm going to start pulling it out here a little ways, and you guys tell me when to stop, when it looks about right. Right there? Okay. Just, I've seen a lot of models of the Earth and the Moon with it being about this close. But you know what? It's going to be farther yet. So you guys tell me when to stop. That's getting closer for sure, right? Now, that looks like it's quite a ways. But you know what? It's going to be even farther. It's going to be even farther. And Melina, keep walking with me. Actually, yeah, you got the idea. Go ahead and grab the pin there. There we go. Awesome. Start backing up for me a little bit. There we go. Stop there. Does that look good?
Yeah!
That's pretty good. You know what? Jack, I'm going to need you to back up a little bit. There we go. Keep going. Keep going. Does that look good? Yeah! All right, keep going. All right, Melina, you back up a little bit too. And there we go. That is how far. Hold that right up here for me. Nice and tall. There we go. Awesome. Perfect. Let's make sure this rope is really tight. Go ahead and pull it in a little bit tight. There we go. That is how far it is from the Earth to the Moon with this scale. Isn't that is like quite a long ways. Now, guys, this right here, if we were to measure this in our miles, this would be 238,900 miles. There's going to be a quiz on that in about 15 minutes. So, I want to make sure you guys remember that. So, it's listen. It's going to be 238,900 miles. You guys say it.
2,100,000 miles.
Was anybody listening at all? Alright, let's try it again. 238,900 miles. Say it. 238,900. Okay. Now, if you were to write that down, it would look just like something like, that many miles. That is a lot of miles. It is bigger than me, isn't it? Now, guys, could you imagine how easy would it be to launch a rocket? You can leave that there for me, bud. We'll leave it there. All right. We're just going to set this right on over here for now. Now, could you imagine getting a rocket from here and hitting that tiny little target over there? That would be pretty tough order to do, right? Now, here's what we're going to do. We're actually going to try to launch a rocket and land it on the moon. But, Emelina, I'm going to give you some goggles here because I want to protect your eyes. You know things are going to get crazy when you're wearing goggles now, right? All right. Now, I need a volunteer who is really, really, really good aim here. Somebody with really good aim to help me out with this. How about, let me see, how about this guy right here in the black shirt? You can help me. All right. Can you stand right over here? Face all of your friends. What's your name, pal? Hunter. Hunter! Everybody say, Yo, Hunter! Yo, Hunter! All right, Hunter. We are going to see if you can. You ever used one of these before? Okay, so I'll show you how this works. Hold on right here. Perfect. And then right down here, this is our launch button. All you have to do is stomp on it. So you have to make sure that you're low enough here. And then when you're ready, stomp on that and see if you can hit the moon. But you have to aim really, really careful at the moon. You know what, Emelina? You might hold that up over your head. There we go. Awesome. All right, dude. Whenever you're ready, let's launch our rocket. That was actually a really, really good shot. That was really close. But you know what? the moon. We were able to fly to the moon. That was a good shot. You got me on that one. Now, good call. Now, we're going to try it again, but let's see. Here we go. Now, we're going to see if we can hit this moon one more time. That last one kind of sailed off. We kind of missed the moon. We kind of went on to Mars and Jupiter. If you miss, that's what's going to happen. Now, let's try that again. Are you ready? All right, go for it, bud. All right. One more try here. You can do it. You got it. All right. There we go. Pretty close. You know, there's actually something wrong with our model here, though. Because is the moon sitting still in real life? No. The Earth or the moon is actually orbiting around our Earth really quickly. And so what we're going to need to do is we're going to need to get our moon moving. So can we make this line nice and tight still? There we go. And now can you, Emelina, walk this way and then walk this way? You be a nice moving target for Hunter to try to get the moon. All right. Here we go. All right, you ready? All right. Whoops.
Mr. Jetpack.
All right. Here we go. All right. Oh! You know, I'm going to call that a hit. Because even though it didn't quite hit the moon has gravity. And I think that was close enough that rocket may have actually been able to start falling into the gravity well here and start orbiting our moon, which is exactly what we want. But is our model still complete yet?
No.
No! Our moon's moving. Our moon quit moving. Why did our moon quit moving? Okay, you can hold still for just a couple minutes. Catch your breath. Now, our Earth isn't, can you please stay on the other side of the tape for me, bud? Thank you so much. Now guys, our Earth is also spinning, isn't it? In fact, it's spinning at like 1,000 miles an hour right at this equator. So, you standing still isn't really fair to our model yet either. So, you know what, Hunter? You need to spin. So, you can grab a seat on that, crisscross applesauce. Awesome. And now, this is going to be pretty tough for you to coordinate. Hold on. Don't spin yet. Because I have to hand you this. And you have to have this. So somehow, you're going to have to aim that. There you go.
Everybody sit on their pockets.
All right. I need everybody sitting flat on their pockets, please. So that way people in the back can see, right? Awesome. And let's put this right up here. All right. Now, are you ready? All right. Now, you look like you're about ready. I'm going to start spinning you. And then your job, you better start moving too, Emelina. There we go. Awesome. There we go. I'm going to spin you and you launch that rocket whenever you think it's time. What are you doing? That's pretty tough, isn't it? All right. You know what? I'm going to make a suggestion to you. Let's set this up here and then slam it with your, there you go. Hit it with your elbow really, really hard. Not yet. That would go up right towards the sun over here. That's not what we want yet. All right, here we go. All right. Here it comes. You know what? And hilarity ensues. Woo! We almost got it. There we go. All right. One more time here. One more try. Sometimes launching rockets can be tough. All right, we'll spin you the other way. All right. Whenever you're ready, here it comes. has to calculate and figure out exactly when and where to launch a rocket and figure out how fast it's going to go, how much weight it can carry, and exactly get all this right and hit the moon. Luckily, back in the 1960s, some really smart people, some physicists, and some rocket scientists, and a lot of really smart people came up with some equations, some math equations that will get us the correct trajectory. You guys say trajectory? Trajectory! The correct trajectory from the Earth to the moon. Now, a trajectory is a path you're going to take, right? So our path from the Earth to our moon, I'll show you this equation in a second, is what we can see it in here. And then we can also have a trajectory. Let's say when you go home today, you're riding in the car, your path that you take home, that's your trajectory. So, are you guys ready for this equation? Yeah. We're going to take a look at this. Now, guys, I want you guys really put on your thinking helmets, your thinking hats, because we're going to memorize this together. We're going to spend like the next 5 minutes doing this. We can get it done in about 5 minutes. You ready? Yeah. Here it is. You ready? And... Oh, I thought this was my cookie recipe. This isn't my cookie. Oh, this really is the equation. All right, so let's start up here at the top. Let's memorize this together. It's going to be V sub 2 equals V sub P. I'm just messing with you. We're not going to memorize this. This is ridiculous. Could you imagine doing all of this math? This is what they had to do in order to get us from the Earth to the moon. Nowadays, we have like these fancy little pocket calculators, otherwise known as cell phones, that we can use to calculate things like this. They had to do all of this by hand. Now, can we leave the tape there, bud? Awesome. Now, you know, guys, good thing for us, we have, like I said, these smartphones and these devices. We don't need this equation for right now, but know that it's there. Now, I tell you what we need to do. I need another volunteer to come help me here. Because I need somebody who can go to space. Actually, we're not actually going to go to space, but we're going to pretend that we're going to go to space. And let's see, oh man, there's lots of great volunteers. Lots of people that can volunteer. Oh, it's overwhelming. Let's see, how about this?
Everybody.
Yeah, everybody. Oh, how about... All right, you got to help me. All right. Awesome. All right, stand right here. Face all of your friends. What's your name, pal? Jace. I need everybody to say, what's up, Jace? What's up, Jace? All right, Jace, we are about ready to go to the moon. But you don't look ready to go to the moon. Are you ready? Okay, he says he's ready. But he's missing something, isn't he? He's missing. Wait. Somebody raise your hand and tell me, because I can't hear what everybody's yelling at me all at the same time. Let's see, what is he missing?
His gear.
His gear! Yeah! We need to keep our bodies safe in space. If we're walking on the moon, we need a spacesuit. Because over here where the sun's shining on you, we can get over 400 degrees Fahrenheit. That would be like some serious sunburn. And then over here on this side, there's no air to keep this side warm, and there's no sun shining on this side over here. So this side over here can get down to like negative 200 degrees Fahrenheit. Really, really cold. That's a huge difference. So our spacesuit really helps to equalize that, or make it even across our whole body. So we have a spacesuit now for you, buddy. You know, do your shoes come off easily? Oh, nice. Right on. That's actually what I was looking for in volunteer this time, was shoes that can be removed easily. All right. Now, can you go ahead and put that on? There we go. Awesome. I'll help you out here. Now, in real life, there you go. In real life, you got it? You got this. All right, easy. Now, in real life, it does take a couple of people to get a spacesuit on. Because spacesuits, if you look at it, they're really, really bulky. And they're full of all these components in there. And they also weigh a bunch. They can weigh up to 90 pounds, or even more than 90 pounds. That's pretty heavy. Could you imagine wearing 90 pounds of clothes? I mean, half of you guys here don't even weigh 90 pounds. Now, all right, can you zip up for us? There we go. There we go. Awesome. Now, you got your spacesuit on, nice and bulky. We can even bulk it up a little more, but I think we're pretty good for right now. All right, now, we got to put our hood on, because that's going to help to keep your head warm. And then, what else do we need?
A helmet!
A helmet! A helmet is going to give us our air right around our face, because that's what we need in order to breathe, right? Because there's no air on the moon. So, you're really skinny? Nice. Well, this helmet ought to fit. All right, here we go. Very cool. There we go. Good. All right, face all your friends. Now, what was your name again, buddy? Jace. Well, we have astronaut Jace here. Everybody say, what's up, astronaut Jace? Yeah, we are about ready to go to the moon. Now, there's something special about the moon's gravity. It's pretty cool. Now, first of all, what's gravity? What's gravity, buddy?
It means like when you jump in high air, it makes the gravity pull you down.
The gravity helps to hold us down. Yeah, when we jump in the air, that's why we're not flying off into space. It's because Earth's gravity is pulling us down. Now, what's really cool is if you weigh 100 pounds here on Earth, let's pretend, Jace, let's pretend you weigh 100 pounds, right? We'll pretend. He weighs 100 pounds in pretend, right? If he goes to the moon, he's going to weigh 16 pounds. You're going to lose like a lot of weight that way. Yeah, a lot of weight. Now, tell you what though, we can't really give you less gravity here on Earth, but we can kind of simulate what it's like to walk on the moon with some moon boots. Oh yeah, they're like portable trampolines. All right, go ahead and put your foot right on in there. Awesome. You ever worn these before? No. Awesome. All right. Here we go. There you go. Awesome. All right, now Jace, you have to be careful. Don't hurt yourself. But walk around with those. You all right? This is why we're wearing a helmet. Yes. There we go. Everybody give him 5. Give him a big round of applause. Awesome. I'll take that. Thank you very much. Let's get that spacesuit off you there. Those are pretty, they're kind of tough to control, but those get really bouncy, and you can like really bounce, really, let me help you here. All right. All right, we need to slow down here. There we go. Awesome. Grab your shoes, you grab a seat for me and put those on. There we go. Let's give him another big round of applause, guys. Now, unfortunately, I am about out of time here, but I have one more thing I have to show you guys here. But I need 4 volunteers to come help me this time. All right, let's see. Can you come help me? And can you come help me? 2. I need 2 more. Remember I can pick volunteers who are sitting with their hand in the air. How about this guy right back here, the Wildcat shirt? And how about this lady right here in the gray? Can you come help me? Awesome. All right. Where you going? Don't go anywhere. Stay right here. Face all your friends. What's your name? Dakota. Everybody say, what's up, Dakota? What's up, Dakota? What's your name? Kenna. Everybody say, hey, Kenna. Hey. What's your name? Caitlin. Everybody say, what's up, Caitlin? What's your name, buddy? Boston. Boston. Everybody say, yo, Boston. Now, these guys are going to help me to launch a rocket. Now, when we go to space, or if we go to the moon, let's say, it takes a lot of fuel, a lot of rocket fuel to go to the moon. And rocket fuel, they use kerosene and oxygen. And then they mix it together and light it on fire, and it gives us a rocket. Now, a real rocket that's going to go to the moon, the Saturn V rocket, used, this is 1 gallon, right? They used 995,000 gallons of rocket fuel. 995, you can just say 1,000,000 gallons of rocket fuel to get us to the moon. Now, unfortunately, it looks a lot like milk, right? The same carton that milk comes in. Now, it is, but it's a perfect visualization for a gallon. So, if you imagine 1,000,000 of these to get to the moon. Now, I wasn't able to bring 1,000,000 of these to the moon. Whoops! 1,000,000 of these with me today, so we're going to use something else. Can you guys put on those goggles first? And And come stand right over here by this table. Yep, right behind the table. Go ahead, right on in there. Go for it. There we go. Fire load in all the way down, bud. All the way down. There we go. Awesome. Now, we're going to use two things for our rocket fuel. We're going to use some water, and we're going to fill this up, just a little ways here, about up to there. Can you hold on to that? And then we're going to fill this one up about the same. Whoop. That's a lot more. We're going to put, there we go, about that much in there. Can you hold on to that one? And then I'm going to hand you this. Just a second. Give me a second to fill this up. And, maybe about there. All right, can you hold on to that one? And then last but not least, right over here. There we go. And can you hold on to that one? Now, the other part of our fuel is going to be an effervescing tablet, just like this, or Alka-Seltzer. And so when this mixes with our water inside there, we're going to get a lot of fizzing happening, and a lot of gas is released. And that's going to build up pressure inside of these rockets, and they're going to hopefully launch that way. Now, I'm going to load these up, but once I put this in there, don't shake them, don't mix them around, hold really, really, really still, don't eat them, don't drink them, don't... Okay, there we go. Now, excuse me, there are some caps here, and I want you guys to put the cap on there, but be very careful. You can push it down a ways as much as you want there, but just know the harder you push it down doesn't mean it's going to go any higher. It might not go off at all. So find a nice place to push it down to. All right. And then when I say now, that's probably pretty good there, Boston. On the count of 3, I want you guys to turn those over. Not yet, not yet. Keep them upright. On the count of 3, turn them over and set them on the pan, on the launch pan, if you will. And then take a step back. 1, 2, 3, go for it. You ready, Nick? Let's go. Step back. All the way back. Here we go. Let's see. Well, that one went. Here we go. Another one? Which one's going to go next? How about we give them a huge round of applause? You should have said that like that. Perfect. Guys, Chase Goggles, thank you guys so very much. Awesome job. Leave that right there for me, buddy. Perfect. Thank you very much. Alright, guys, did you guys have fun today? Yeah! Awesome, I had a blast hanging out with you guys. I had a blast hanging out with you guys today also, talking about all this fun science stuff. We get to do like all sorts of really fun science stuff like this, and I get to have fun doing this with you guys. And you guys, I can tell a lot of you guys had a lot of fun with me today. I want you guys to keep thinking about all that science fun that you had. And check this out, you guys right now are in a really cool place if you want to know more about science and getting to the moon. And let's see, what else? Walking on the moon. Let's see, about space and space science and moon science and all this other stuff. You guys are in a great place to find a book and check out a book. You might have 1 or 2 around, right? Yeah, right. So guys, thank you guys so very much for all your help. Do a huge favor for me though. On your way out, please stay back on that side of the table lying here. Please don't touch anything on my table unless I ask you to, okay? Perfect. Thank you guys so very much for all of your help today. Have fun.